everybody, my name is Susie and I'm a PhD student from Flinders University in Australia. My poster is all about predicting the oligomeric state of bacteriophage proteins. In case you don't know already, bacteriophages are viruses that infect bacteria and they're really important both in the environment and for human health as well. One thing that makes them really difficult for us to understand is that about 65% of the proteins in bacteriophages have no biological function, which makes it really difficult for us to understand what it is that they do. One way that we've been looking at trying to understand the proteins in bacteriophages is by predicting their structures using AlphaFold. One thing that makes this challenging though is that we can generate AlphaFold predictions for these proteins. However, it's still quite challenging trying to predict the complexes that these proteins form, as often they form large homomeric complexes with several different subunits. And AlphaFold doesn't tell us this type of information, it just generates the structures for a single monomer. So what I've been doing is looking at developing methods for coming up with ways for predicting the specific oligomeric state of a bacteriophage protein. That is, whether or not it performs a homomeric or a monomeric complex, and how many subunits are in that specific complex that it forms. The way that I've been doing this is I've been taking the sequences of different phage proteins and generating AlphaFold structures of them using AlphaFold multimer with 2 to 10 different subunits. Once I've generated these protein structures, then what I do is I look at the quality of the interfaces that are formed in these complexes, and I use these metrics that are generated about the interfaces in my AlphaFold complex to try and predict what is the most probable homomeric structure that this protein might form. On my poster here, you can have see an example where I've folded the major capsid protein of a really popular bacteriophage called bacteriophage lambda, and was able to predict that it forms a complex with 6 different subunits. As you can see the details on my poster here, but I've specifically looked further at how we can use these metrics computed from the AlphaFold interfaces to predict whether a protein is a homomer or a monomer, and then predict how many subunits that complex uses. One thing that is really cool from this work that I've done is that I've shown that by predicting how many subunits are in a bacteriophage complex, that we can use that information to help us understand some of these proteins a little bit better. One specific protein that I looked at, I was able to find that it forms a pentameric structure, so it forms a structure of 5 different subunits, and this structure resembles something that looks like a membrane protein, which might indicate a really interesting mechanism that the virus could be using to infect the bacteria. I'm really happy to talk to you more about this, so please feel free to find me at the conference or send me a message or an email. Thank you.